Welcome judges to our project on Dino-Nuggetology. We are Team Decaffeinated, comprised of So Hirota, Penny King, and Garvey Lee, and this is our DataHacks project submission for 2024. Our project goal is to classify the shape of various dinosaur nuggets and be able to detect anomalies, which in our case are deformed nuggets. Our idea for this project stemmed from childhood memories of eating misshapen dino nuggets that did not look at all like the packaging. Being able to detect anomalies in chicken nuggets can help with quality control and also has applications for anomaly detection in general. On the right, you can see a normal pterodactyl dino nugget on top, and on the bottom, you can see an example of a deformed nugget. All of our data we collected ourselves using the Dino Buddies brand from Costco. In total, there are 7 dinosaur shapes, which are T-Rex, Triceratops, Pterodactyl, Stegosaurus, Brontosaurus, and Parasaurolophus. And there are also an additional shape we created for the purposes of our assignment, the deformed shape. We took over 200 photos of various dino nuggets on a white paper plate, all from the same distance for the camera. We created additional data points by mirroring photos and rotating our photos in increments of 15 degrees. This allows our model to generalize to various orientations. In total, this resulted in over 10,000 photos in our dataset.
Pre-processing our data consisted of the following steps. We converted our RGB JPEG images into grayscale images with values ranging from 0 to 255 and reduced the image size to 200 by 200 pixels using bicubic interpolation in order to standardize our images. To create an image containing only edge information, we first use a Gaussian low-pass filter to blur the image to mitigate any potential noise, such as stray breadcrumbs or the textures of the dino nuggets, and we then calculated the first-order gradient image in the x and y directions by convolving the image with 2 Sobel kernels. With the gradient image, we further thresholded the image to binarize it or make it black and white, resulting in a clean outline of the nugget. With this initial set of data, we decided to create more images by augmenting the pre-existing images. So, for each image, we rotated it in 15-degree increments and created a mirrored version that was also rotated, thus creating 23 new images or data points per sample.
For our model, we decided on a convolutional autoencoder. This is because an autoencoder is good at learning low-dimensional representation of images. The idea is to train a model to learn representations of normal nuggets, so it will fail to reconstruct deformed nuggets. We set a threshold of error for reconstruction to detect if a nugget is deformed or not. The encoder and decoder consist of 3 convolutional layers and 1 dense layer. The convolution layer helps reduce the dimension of the input, and the dense layer flattens the image into a 3,000-row latent representation.
Here's a demonstration of our model. In our GitHub repository, you can find demo.ipymb, which shows how you can use our model for classification. We were able to create a model which was able to classify nuggets as either normal or abnormal. Our model has potential use cases in product quality detection, specifically in catching less than ideal products before selling. This model also has applications outside of Dino-Nuggetology. Our image classification model can be applied in anomaly detection more generally for various other cases. Thank you for listening in to our Dino Nugget research, and hopefully you are now inspired to not only eat some Dino Nuggies yourself, but also research more into Dino-Nuggetology.